Don't forget to subscribe and ring that bell.
Hey, 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 we're here, finally. This is the last video of the January 2024 Algebra 2 Regents examination. We are going to cover short answer problems 33 through 37. They are the 4-point questions and the 1 6-point question. So let's do this, shall we? As previously stated, there are 4 questions and they are all worth 4 credits each. You can get partial credit. So if you can do a problem in the calculator without showing your algebraic work, do it in the calculator, write down the correct answer, and at least get 1 correct point. Okay? Let's begin. 33 reads, a researcher wants to determine if nut allergies and milk allergies are related to each other. The researcher surveyed 1,500 people and asked them if they are allergic to nuts or milk. The survey results are summarized in the table below. Okay, so in this bottom corner, there are a total of 1,500. They say that right here. Okay, and there are a total of 45 that are allergic to milk. Not allergic to milk are 1,455. Okay, and these two should add to my 1,500. And then down here, my 3 and 12 give me 15 that are allergic to nuts. And that means there is 5, 85, 14, 85 that are not allergic to nuts. And if I add those up this way, that also gives me my 1,500. All right? So we got our totals. We got everything in front of us. It says determine the probability that a randomly selected survey respondent is allergic to milk. So out of all 1,500, okay, allergic to milk. That's this column right here. That is, there are 45 total. Whether they're allergic to nuts or not isn't significant here. I just want everybody that's allergic to milk, and there's a total of 45. Okay? So I'm going to put that here. And if I put that in our calculator, here we go, circle of death. There it is. See that little circle? All right, here we go. So I'm going to take my 45 and simply divide it by 1,500. It's 0.03. So they just want the probability. They didn't say percent. So 0.03, that's legit. Okay, that wasn't too bad. Next, they say determine the probability that a randomly selected survey respondent is allergic to milk given, let's do this in playful, given the person is allergic to nuts. Okay, here's the thing. We are given that they are allergic to nuts. I don't care about this one. I am given, let me get rid of this. This is what I'm given to pick from. These 15 people. That's it. I don't care about anything else. Okay? Out of these 15 people that I'm given, how many are allergic to milk? 3 out of the 15. 3 out of the 15. All right? And if I do that, that's 1/5 or 0.2. So 0.2. If you, some people like to put the zeros in front. You can notice I didn't put the 0 up front here. You don't need to. But there you go. Now, the last one says, based on the survey data, determine whether nut allergies and milk allergies are independent. You really just did the work for that. Let me extend the page. And what does that mean? If the probability of milk, thank you, is equal to the probability of milk given nut allergies, okay, if they are equal, they are independent. If they are not equal, they are not independent. We just figured this one out in part, no, the first part. See, that's 0.3. Ooh, I lied, 0.03. The next one is 0.2. They're not the same. So guess what? They are not independent. Make sure you answer this, okay? Justify your answer. This is justification. The work is above. Done. 34. Algebraically solve for x. 2x equals 6 plus 2 times the square root of x minus 1. In order to solve for radicals, I first want to get the radical alone. I know that by squaring something, it undoes a square root. But before I undo that square root by squaring it, I need to get it alone on one side. So, first thing is I'm going to subtract 6 from both sides. 2x minus 6 equals 2 times the square root of x minus 1. Now I'm going to divide both sides by 2. That means I can divide everything on this side by 2. X minus 3 equals square root of x minus 1. I guess I didn't need to put these here yet. Now that I have this radical alone, now I can square this. These will cancel, and I have x minus 1. But I got to square this entire side. Okay, x minus 3 times x minus 3 is going to be x squared minus 6x plus 9. Okay, x squared minus 6x plus 9. Right? I just move everything over to one side by setting it equal to 0, and then I just factor and solve. So let's subtract an x and add a 1. I've got x squared minus 7x plus 10 equals 0. Oh, I can do this in my sleep, and you should be able to as well. Two numbers that multiply to be positive 10. Okay, I'm using x's. But they should add to negative 7. That means they should both be negative. Guess what? It's 5 and 2. Okay, and if I solve both of those, I get x equals 5 and x equals 2. But this, my friends, this is a short answer problem. We need to check for extraneous solutions. All right, so I'm just going to go right back to the beginning. It doesn't tell us we need to check for extraneous solutions, but we do. I'm going to put into here both of my x's and see if they work. Let's start with 5. Okay, I'm going to put 5 in here. 2 times 5 is 10 equals 6 plus the 2 times the square root, I'll be okay, of 5, because that's my x here, minus 1. 5 minus 1 is 4. The square root of 4 is 2. 2 times 2 is 4 plus 6. That actually equals 10 equals 10. So 5 works. Let's check 2. Okay, 2. It's 2 times my x, which is 2, equals 6 plus 2 times the square root of my x, which is 2, minus 1. I don't know why I was going to put a parenthesis there. Looks like an 11. Okay, 2 minus 1 is 1, and the square root of 1 is 1. 2 times 1 is 2 plus 6. Does that equal 2 times 6? No, it doesn't. If this was a minus sign, they'd be equal, but 4 does not equal 8. So this does not work. That's an extraneous solution. You don't have to write extraneous solution unless it tells you to write extraneous solution. I mean, I always do because I feel like a smarty pants. But if you just cross it off, signifying it's not an answer, this is 100% correct. Okay? Always check answers if you have a fraction involved to make sure the denominator is not 0. And when there's a radical involved, to make sure both of the sides are the same. There we go. Paragraph after paragraph. 35. During the summer, Adam, okay, here we go. Adam saved $4,000 and Betty saved $3,500. Okay. Adam deposited his money in a bank A at an annual rate of 2.4% compounded monthly. Betty deposited her money in bank B at an annual rate of 4% and compounded quarterly. Write the two functions that represent the value of each account after T years. If no other deposits or withdrawals are made, where Adam's account value is represented by A of T and Betty's by B of T. You cannot write Y equals, okay? They say A of T. Yep, that's weird. I thought I clicked on that. So let's just get rid of the red. Let's keep everything coordinated. You gotta coordinate, kids. Adams. Now, it's always the beginning amount. He put in 4,000 times 1 plus your rate. But be careful. Your rate, first of all, is 2.4%. I want to get rid of the percent, so I divide it by 100, and I get 0.024. Why did I write this up here? Because I got to divide by how it's compounded. It's compounded monthly. That means once a month. That is 12 times a year. That means this number below here should be 12. And I raise that to that same number, 12 to the t. Okay? So whatever my compounded, if it's monthly, that means there's 12 months a year. That compound number gets multiplied times the exponent and divides my rate or percent. Okay? And we're going to do the same thing for Betty. This time Betty starts, her initial amount is 3,500. It's 1 plus, her rate is 4%, which is 0.04. But if she, okay, I got to put this number down here, and then I take that same number and multiply it times my exponent's time. If it is quarterly, that's 4 times a year. So the 4 goes down here, and the 4 goes right here. And that looks like a 9, so let's just make it look more like a 4. That's it. It's tough when it's compounded because that's brief, if at all, that we cover this in the year. Because, again, there's so much to cover in the year, and there's only so much we can do. But here you go. That's it. These are the two equations represented by A of t and B of t. Now, the second part of this, I think, is a gift, as long as you get the first part done. It says, this drives me crazy funny, using technology. That means you can use your calculator for this. To the nearest tenth of a year. Remember, that's your t variable. It's the exponent. How long will it take for the two accounts to have the same amount of money? How long will it take for those equations to be equal? So I'm going to take 4,000. I'm going to put this in y1. 4,000 times 1 plus 0.024 over 12 raised to the 12t. I'm going to set that equal to, what I'm going to put in y2 is 3,500. 1 plus 0.04. Again, I don't know why I can't write that 4 in the exponent. Now it looks like A4. Kids. Mr. Visca needs coffee. And 4 times t. I'm going to put that in y1 and y2 and see where they intersect. That's technology, kids. So let's go ahead and do this. There you go. So we got, here's the calculator. Here's the big screen. Turn this on. Big screen. Clear this out. And we got 4,000 times 1 plus alpha y equals enter 0.024 over 12. Pop out. Raised to the 12, and we are using x instead of t. Yep, that's got to be an exponent, children. 12x, delete. All right. Now, the second one here will be Betty, and she had 3,500, and that is 1 plus 0.0. Let's fraction it. Let's not get cute. Alpha y equals enter 0.04 over 4 raised to the 4x. I'm going to graph this. We might not be able to see it in 10 by 10 window. We might have to expand our window or zoom out. In fact, I don't see it anywhere on the screen. You see the top here, that yellow circle spinning. It is not done graphing until that yellow circle goes away from the battery. All right, it's still working. It's still working. Kids, did I ever mention to you that still working? There we go. I don't see anything. How come? Look at my initial amounts. I'm starting at 4,000 on the y-axis, and I'm starting at 3,500 on the red one. I'm only going up to 10. So when I hit zoom, I'm going to pick zoom fit. That tries to put all the important things in one screen. That's choice 0 down here. Okay, and I'm going to hit enter. And you can see my yellow circle bob here starting to spin already. And I don't know why this is taking so long, and it's so complicated. There we go. There we go, Peter. There we go, Peter. Look at that. So that's my man Adam's money, just climbing. And here is Betty's money. Now she started at 3,500. So at the start point here is 4,000, and here's 3,500, and they intersect. Look at us go right there. This is where they're equal. Okay? So I'm going to use the intersect function. Second calc, or I guess that's trace. Calc is above it in blue. Hit enter. I'm just going to, I mean, I don't have to. There's only two functions. So I'm just going to get slightly closer to it. Slightly closer. And I'm just going to hit enter 3 times. 1, 2, 3. You'll see in the bottom left, it's 8.437. So X or T is 8.437. This is really a T, is approximately. And they want that to the nearest tenth of a year. So we'll call it 8.4. There you go. I think this is another gimme. If you understand graphing sine and cosine, this should be fantastic. 4 points? Wow. On the graph below, draw at least one complete cycle. So we're just going to draw, that's all we're going to draw is one cycle, because they're saying at least one. So we draw one, you can draw 7, go nuts, but why would you? One cycle of sine. Sine right now is the S. That means it starts in the middle, up, down, up. Okay? So sine looks like that. It passes through the point 0, 2. So 0, 1, this is 0, 2 right here. It's got to go through this point. It has an amplitude of 3, a period of pi, and a midline at y equals 2. So the midline, which we don't really have to put on the graph, is right here. Right at y equals 2. And that's good because that's a point we need. Okay, that's the midline. If you look up here, that's the middle of my sine curve. So it's going to start at 2. All right. What else do I know? So let's do this in red. It's going to start here. Okay. Pi means that's the length, the period of one cycle. So my sine is going to end at pi. So let's look up here at my S again. So if it starts at 0, right there, boop, boop, this is going to end. This will be where pi is. And in the middle, right on the midline, is pi over 2. It's half of pi. So I'm going back to my graph. Okay, it ends at pi right here. And the middle is also right on that midline. Now, the amplitude is 3. What that tells me is that's how far up and down from the midline I go. So if I'm at 2, I go up 1, 2, 3 spots to 5. And that's in between these first two. So this line right here, I'm going to be up at 5. We'll do that in red. All right. And then from 2, I got to go down 3. 1, 2, 3. So that is at -1. And in between these two, I go down to -1 right there. So this goes. Let's go. Let's actually go through this. How about that? There you go. That's it. That's one sine curve. It touches the point 0, 2. That's that point right there. Okay. It has an amplitude of 3. It goes up 3 from the midline and down 3. And the midline is here, right? That's it. That is perfect. Goodness gracious. Now, again, on your graph, you don't need this. Yeah, okay, I thought I hit that there. You don't need the midline. You don't need these arrows I drew. I mean, that's all you need. Okay? Now, it says, based on my graph, states an interval. You just need to be one. You don't need all intervals where the graph is increasing. That means it's going up. So either from here to here, my graph is growing. It's going up. Or from here to here. Let's pick the first one, starting at 0. Okay, so what is this? Notice here's 1 pi. These are quarters. This is pi over 4. And this is 3/4 pi. Okay, I'm just going to go from 0 to pi over 4. So that's on the x-axis, from 0 to pi over 4. You could have said from 3/4 pi to pi, because it goes up there. You could have said from 3/4 pi to pi. And you could write it, the words instead of inequalities. Either one. You just need one. I'm just going to go with this one. Simple as the first one. Done. This is it. This is part 4. Answer the question. There is only one question on this part, and it is the question on the test because it is worth 6 points. All right? 37 reads, a manufacturer of sweatshirts finds that profits and costs fluctuate depending on the number of products created. Creating more products doesn't always increase profits because it requires additional costs, such as building a larger facility, hiring more workers. The manufacturer determines the profit, P of X, in thousands of dollars. Okay, so first of all, P is in thousands of dollars. So if P is 7, that's $7,000. Okay, as a function of the number of sweatshirts, X sold in thousand. So if I said if X is 10, that's 10,000. The function P is given below. P of X, I'll just highlight the X's in blue because I did the P in green. P of X equals negative X cubed plus 11X squared minus 7X minus 69. Guys, graph Y equals P of X from 0 to 9 on the X-axis. That is a gimme. Okay, let's first take a look at this. Okay, let's not get too excited here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There you go. 7, 5. There you go. They go up by ones. But notice, let's clean this up here. Notice every 2 tick marks is 30. So it's 30. 2 tick marks, I add another 30. That's 60. 2 tick marks, it's 90. 2 tick marks, it's 120. Okay, 2 tick marks, it's 150. I don't think we're going to have to go higher, but if you wanted to, you can call this 180. All right, and then I go down to, that's negative 30, down to negative 60, down to negative 90. All right, so here we go. I'm going to simply put this in the calculator and look at my table, okay, from 0 to 9, and plot the numbers here. And I'm going to make my table reflect the axis, okay, and the scale on the axis, meaning my x-axis is going to go from 0 to 9 by ones. 1, 2, 3, 4, and so forth. My y-axis is going to go from 0 to 1, or excuse me, from negative 90 all the way to 180, but I'm going to go by 30s. 30, 60, that's what I'm going to do. Make life a lot easier. So let's just go ahead and do that, all right? Turn this on, and we'll go here. Clear this, and my equation is negative x cubed, pop off that exponent, plus 11x squared minus 7x minus 69. Okay, did I write that in there correctly? It is. I typed it in. Now my window, my x is going to go from 0 to 9 by ones. And my y is going to go from negative 90 to 180. And I'm going to go up by 30s. In fact, that's all I need to do. So if I graph this, this is what my graph should look like. Okay, from 0 starts here. It's going to go down, then it's going to come up and come back down. This is 9. Okay, but instead of just drawing this curve, for the love of God and everything holy, look at your table from 0 to 9. From 0 to 9. That's all I care about. I don't care about 10 here. 0 to 9, that's what they want. So I'm going to put this off to the side here. And I'm going to make sure I plot these points pretty freaking accurately because this is a 6-point problem. I don't want to lose it. 0, it's negative 69. So that's probably somewhere right around here. 1 is negative 66. So that's, I mean, it's not going to change that much. A little bit below negative 60. 2 is negative 47. Okay, 2 is negative 47, right around there. 3 is negative 18, so I don't know, like right around there. 4 is positive 15, so 4 is 15. 5 is 46, so 5 goes 46, probably closer to here. 6 is 69, so 69, I don't know, right around there. 7 is 78, it's not quite to 90. 8 is 67, so it comes back down. I'm almost where the 69 one is, and 9 is 30. It comes down right here. So I'm just going to connect these dots. Guys, that's probably 2 points. I mean, you're just copying from the calculator. All right, well, let's take a look here. Over the given interval, that means from 0 to 9. That's the interval they want us to graph here. Okay? Over that given interval, state the coordinates of the maximum of P and round all values to the nearest integer. Explain what this point represents in terms of the number of sweatshirts sold and profits. Maximum, guys, oh my goodness. There's no way you're going to get one this easy. But here we go. They want me, the maximum point is somewhere around here. So I'm going to go second, trace, which is the calculating. I'm going to pick maximum. And I've got to be to the left of it. You see the bottom, it says left bound. So anywhere to the left, as long as I'm to the left here, and I'm already to the left of it, so I'll hit enter. Now it's saying to go to the right of it. I got to go to the right, which this is the part that stinks. Just keep on pressing it. Okay, I'm to the right of it right here. I'll hit enter. Now see the bottom says guess? I don't move it at all anymore. I just hit enter again. And it gives me this point, 6.99999. Let's round that. They'll round to 7. So it's 7 and 78. Okay, because they want that to the nearest integer. 778. Okay, so what does that mean? Remember, the X is the sweatshirts sold, but it's in thousands. And the Y, which is P of X, is in dollars, thousands. So this is the sweatshirts in thousands. And this is my money in thousands. Now, remember, this is the maximum. So our profit, the highest our Y value goes. Remember, Y is the, okay. Y is the profit. The highest we go, okay, is 78, but it's in thousands. So it's our max profit is 78,000. Remember, that's in thousands. Dollars when 7,000 sweatshirts are sold. 7, because that's also in thousands. So when 7,000 sweat, yeah, I'll be okay. Shirts are sold. That looks like a 7. Now it looks, no, it doesn't. There you go. There you go. That's the max point, and that's what it means. I mean, that was, oh, Lord, kids, Lordy. We really haven't done any math. We haven't done any, like, calculations or algebra. Determine how many sweatshirts to the nearest whole sweatshirt the manufacturer would need to produce in order to make a positive profit. Guys, again, no algebra. There's no, okay, there is no way you are going to, that would be nice that erased. Who cares? There's no way you're going to get another problem like this. Remember, my profit is the Y axis, right? Anytime I'm above it, okay. Anytime I'm above it, I got a positive profit, right? Anytime I'm below it, I've got negative profit. So they're saying how many sweatshirts before I get into the positives. So I'm in the negatives here. I'm in the negatives, and these blue dots I'm doing, these are all negatives, negatives, negatives. Right here is where it changes to be positives. So I really just need to find the 0. Because once I go this way, I'm in the positives. I'm above the x-axis. I have positive y's. I mean, lordy, lordy, lordy. Lord. Okay, now let's go second. Trace. And this time I want the 0. Okay, oh, and I'm all the way over there. I wish sometimes I would just hold down. There it is. I got to go to the left of it. I'm clearly left. Here's my 0, and I'm left of it. I hit enter. Now I got to go right of it. Okay, I just got to go to the right. Okay, so here's the 0, and I'm clearly right of it. I hit enter, and I hit enter one more time. 3 point, what's that? 3.5488. I don't know. Let's call it 3.5488. Okay, so that's when my x value is approximately 3.5488. But remember, that's in thousands. I need to multiply that times 1,000. That means I moved the decimal over 3 times, and I've got 3548.8 to the nearest whole sweatshirt, which means that will go up to a 9. 3549 sweatshirts. That's how many you need to sell. Justify your answer. We did. I mean, justify shows math work. I don't know. I guess I can set this equal to 0. I mean, we don't have to factor. We can't factor and solve. Okay, x equals 3. Okay, and p of x equals 0 at an x. And there you go. How did I get this number? Well, I found the 0. Or maybe you can write 0 function for justification in your calculator. 0 function. Either one, there it is. It's right here. I mean, if you want to put 3.5488 right there at the 0, you can do that too. You're done. That was such an easy 6-point problem. It was crazy. You know what? You got this. There's a big curve in this exam, and you'll do well with it. All right. We'll see you. Good luck.
Don't forget to subscribe and ring that bell.